So let's say you're doing your calculus homework one night and you find yourself looking at this limit problem. It doesn't appear to be too intimidating, but as you try to solve it, you soon come to the realization that the limit is 0 over 0 for the x value shown. Normally, if the denominator of a function went to 0 or the numerator went to infinity, the limit of the function would be infinity. And if the numerator of a function went to 0 or the denominator went to infinity, the limit of the function would be 0. But when both the numerator and the denominator go to the same extreme on the number line, what do? The answer is to use L'Hopital's rule. L'Hopital's rule is a rule dictating that when a limit goes to 0 over 0, infinity over infinity, or negative infinity over negative infinity, the actual value of the limit is equal to the derivative of the numerator over the derivative of the denominator. It may sound complicated, but it's actually pretty simple. Let's go back to the original problem. As you can see, the derivative of the numerator is 3x squared minus 14x plus 10, and the derivative of the denominator is 2x plus 1. If we solve both of these for x equals 2, then we get a real, rational answer of negative 6 over 5 for the limit. Now that we've got a grasp on L'Hopital's rule, let's tackle a harder problem that requires it. Now if we take the derivative of each side of this fraction, we get e to the x minus 1 all over negative sine of x. So when we solve it for 0, we get 0 over 0 again. In this situation, we'll have to use L'Hopital's rule again, which yields a second derivative for each side of e to the x over negative cosine of x. Now if we solve this function for x equals 0, we can finally get an answer of 1 over 1 for our limit. So that's L'Hopital's rule, the principle stating that the limit of a quotient function is equal to the derivative of the numerator divided by the derivative of the denominator if the original limit solves to 0 over 0, infinity over infinity, or negative infinity over negative infinity. It's simple really, and that's all there is to it. Thank you for watching this video, and I hope you found it informative.